that we took a lot longer going through just one lesson, but I promise you it won't be like that for all of these, okay? So we'll go through these a lot faster, but remember, you have to have your video cameras on, and at least, I gotta be able to see some beautiful portion of your face. So Sarah, Anthony, Tristan, if you could turn on your cameras for me. Everybody else, if I could see at least, the top of your head or the side of your face. I don't really care, right? It's dealer's choice there. Okay. All right, so let me start off with our schedule for the rest of this unit here to give you an idea as to what we need to accomplish, okay? So let me share my screen with you guys. I know that that's a big question, and a lot of you already, I noticed a lot of you have already accomplished some of the things that I'm gonna, assign, which is awesome, right? I assigned them, but a majority of us were still behind a little bit. So if you're ahead of the game, by all means, keep rocking and rolling here. If you're not, this is kind of your chance right here to get caught up and stay on schedule. All right. So the schedule looks like the following. All right. So yesterday was Wednesday, right? Yesterday was Wednesday. We went through 3.1 together, right? We went through 3.1 together really in depth because obviously that builds for the rest of this. All right. So we went through that. We were assigned to do these two quizzes. Okay. Now today we're going to go through 3.3, 3.2, 3.3, 3.4, and 3.5. Okay, we're going to go through all of those. Now, it seems like a lot, right? But if you notice here, you've got multiple quizzes in each of these units. All right, you've got multiple quizzes in each of these units. So it's actually not as much as we make it seem. But something that I'm going to change, okay, something that I'm going to change moving forward is some of the longer assignments that are in a unit, right? If they seem duplicate to me, right, like you're taking 3 quizzes. So why would I make you take 3 quizzes and then do a whole nother activity? All right. So what I'm going to do moving forward is I will make those activities extra credit. Okay. So you have 2 extra credit opportunities here immediately, right? And by all means, you do not have to do them, all right? This is where I'm saying it's your choice. If you've already done them, awesome, congratulations on your extra credit, right? If you haven't done them, again, this is a little bit of breathing room for you. You can choose to do it and make it extra credit, or you can skip it, right? And just keep going on with your day. All right, so this is what we're gonna accomplish today, Thursday. So that means for homework, you'll have to do all of these quizzes. All right, now for the weekend, right, whether that's tomorrow, Saturday, Sunday, whatever, okay, you're going to cover the rest of this. All right, but what I'm gonna do differently this time, instead of just letting you go on your own this weekend, what I'm gonna do is tomorrow morning I will post a video lecture. So similar to what we're going to do in class today, except obviously you guys won't be there for it. So I will post a video lecture for you. All right. It'll be, again, maybe an hour and a half, maybe 2 hours at max, but it'll be about an hour and a half video that you can watch either in addition to or in place of going through the notes by yourself. Okay. So then you should be able to complete the rest of these quizzes. Okay, come back on Monday. We're going to go over a review of all of 311 together. All right, so we're going to go through the review for 311. And what you're going to notice again is we are totally skipping the teacher scored test. Okay, so you will only have to do the computer scored test. You will not have to do that teacher scored one. Okay, so again, this is my way of trying to make sure we're focusing on what's important. We're eliminating some of maybe the busy work or the duplicate work, right? And that you're still able to be successful here. Okay, so this is what our schedule looks like for Algebra 2. Pre-calc kids, you obviously have, a little bit more work with the pre-calc stuff, and we'll talk about that later. Okay, but again, this is my way of trying to make sure that, I'm lightening your load a little bit, or if you've already worked ahead, awesome, right? You're going to get bonus points for working ahead or doing those extra journals. All right. And again, I'm going to highlight here, when we're skipping activities, it's going to show up as a 0. So the only grade that I'm going to focus on and that I will send out to you and your parents is going to be that grade to date. Okay. And I'll make sure that I'm very, very specific about that moving forward here. Okay. But I want to give obviously everyone an opportunity. Does anyone have any questions here about what the schedule looks like for this weekend? Anybody? Okay, awesome. For my people who have worked ahead, by all means, you can continue to work ahead. You can take a breather this weekend, right? If you've already finished all of Unit 3, by all means, you can relax a little bit if you want, or you can keep charging ahead. That's the beauty of this. That's the beauty of this Apex program. Okay, but bare minimum, you need to be with me on my schedule because we're going to walk through notes together. Okay, so then moving forward here, peoples, I am going to walk you through the notes similar to what we did yesterday with maybe a slight change or two, okay? And again, I am not saying that you cannot go back and do this on your own by all means. Again, that's the beauty of this online program here. But what I am saying is that I'm going to take you through some things rather quickly. And again, try to hit the highlights for you so that you can understand, be successful, and also I'm adding in additional things as we go along here. Okay, so if I can share my screen with you guys, we will get rolling here. All right. So yesterday, again, we overviewed Unit 3, okay? We overviewed Unit 3, and I will, I will post that that note slide deck that we went through yesterday to start off class about quadratic functions, about parabolas, and I'll release that to you on Google Classroom later. All right, but we went through lesson 3.1, and that was all about factoring x squared plus bx plus c, right? And by factoring, we mean breaking that into two smaller functions, right? So it was like x plus or minus p, multiplied by x plus or minus q, right? So factoring those guys out. And if yesterday made sort of sense to you, but maybe not fully sense, it's going to make a heck of a lot more sense today, because now what we're doing is we're adding that a value. Okay, so we're now factoring ax squared plus bx plus c. So again, we go from just the 1x squared here to now ax squared. So it steps up just a little bit here. All right, with the overview here, okay, great. Did we just learn this? Yes and well, yes and no, right? So we're gonna follow kind of the same process, right? We're still gonna factor this trinomial into two binomials, right? But it now has this a factor here. So it gets stepped up just a little bit, and it's when, again, the leading coefficient is something other than 1. Okay, so if a is not 1, that's what we're gonna be focusing on here. All right. So moving forward here with the study, okay, with the study here. All right, they give the example as a pool table, right? So you know that this middle is 2x and you want to add 2 on either side. Okay, same thing. You know that this one is x long and you want to add 2 on either side. Okay, again, just a real world example of how you might look at this. Okay, so to figure out how much you need to cover, right, how much area you need to cover, you would be able to do something like factoring out the dimensions, okay? And again, quadratic trinomial, all right? The reason we know it's a quadratic is because it has x squared and an x factor, right? So it has x squared, x, and c, right? It cannot have anything higher than this x to the power of 2, or x squared. If it is x cubed, it is not a quadratic, all right? And then again, it's a trinomial because it has 1, 2, 3 factors there, all right? And again, we're moving forward with this being anything other than 1, okay? That leading coefficient, so a is anything other than 1, all right? And for the first step in factoring a trinomial, it looks like you're trying to find a common factor, okay? So again, common factors is can you divide every term by the same number or by the same variable? All right, so what that might look like here is example 3, okay? Or sorry, example 1. It's got 3x squared plus 9x plus 6, okay? You can divide all of these numbers by 3, okay? So 3 divided by 3 is 1. Right? So you end up with x squared. 9x divided by 3, that gives you 3x. Okay? 6 divided by 3, that gives you 2. Okay, so because all of these can get divided by 3, you can write it as such. All right. And then what we can do to combine like terms or to combine terms, right? We combine all of those threes by putting them on the outside of our parentheses. All right. And then just like we learned yesterday, okay, you can then factor this trinomial. Okay, you can factor this trinomial using the process that we learned yesterday. Okay, you can make these two factorials. Okay, and then that's again, that's just how you do this one. So it's, if it's can be divided by the first number for all of them, you divide, you pull it outside of the parentheses, and then you factor like normal. Okay, so same thing here, you can divide by -2, right? All of these values get divided by -2, so you're left with x squared minus 2x minus 15, right? And then when you factor out x squared minus 2x minus 15, you're left with x minus 5 and x plus 3. Okay, and again, always the way that you can check yourself is multiply these guys out. Multiply these guys out. And you should get back to the original here. All right, you should get back to the original. All right. Again, it is possible for the common factor of a trinomial to be a variable, right? So all of those examples just used the numbers, the first numbers. If I zoom in here, right, we can see that this is x cubed plus 7x squared plus 12x, right? Well, all of these have an x that we can divide by. So if we pull x out of every single variable, right, we're now left with something that we're more comfortable with, that quadratic equation. So that x squared plus 7x plus 12, right? And we factor this out and we know that it's going to be plus 4 and plus 3 because of that process that we talked about yesterday, right? Because of that process that we talked about yesterday. And what I'll do here, I'm going to share my screen with you. All right. So what this ends up being, and the next couple of slides on Apex, we'll talk about that here. Okay, but what this ends up being is looking at, all right, so again, if the leading coefficient is a common factor, so if A right here is a common factor, if I can divide everything by A, it ends up looking like A multiplied by, again, the thing we're most comfortable with, A plus or minus P, or sorry, X plus or minus P multiplied by X plus or minus Q, okay? And again, to remind you, how we got P and Q was we found factors that when multiplied together would give us the value C. So if C was equal to 4, right? If C was equal to 4, P and Q would be 1 and 4, 2 and 2, and 4 and 1. Right? Because those are the three combinations of numbers that are going to give me 4. All right. Then to figure out if it's the right value, P plus Q has to equal B. P plus Q has to equal B. So if B is positive 4, right? 1 plus 4 gives me 5. Same thing, 4 plus 1 gives me 5. Right? So therefore, I know that my answer is going to be 2 plus 2 because that's the only one that gives me 4, right? It's the only one that gives me 4. So in this example that I just made up, you would have x squared plus 4x plus 4. When I factor that out, it's going to be x plus 2, x plus 2, all right? Now, again, the only thing we did differently is that maybe we had to factor out our A value ahead of time, right? So, and we'll work with more examples about what that's going to look like, but this is just to remind you of what we did yesterday here, okay? So now we're working on how do we figure out this A value? How do we pull that A value out to get to something that we are more comfortable with, all right? So if I go back to our Apex, okay? So again, we just looked at 2 examples of, all right, what if it is a number great. We can pull that out. If it's a variable still, we can pull that out. And if it's a combination of number and variable, right? So right here, 7x, we can still do that, right? And we can get to something that we are more comfortable with factoring. So, all right. So again, walking you through quickly what these steps would look like here. All right, if we had negative x squared minus x plus 6, okay, we could factor out a -1. We could factor out a -1 to get to something that we're more comfortable with. So we factor out a -1 from each side, right? We pull that out. Then we simplify so we can collect all of the -1s. All right, we simplify. Then we're left with -1 multiplied by our quadratic trinomial that we are more familiar with. All right, so we can factor just that quadratic trinomial, right? And so since it's -6, I've got to have something that's positive and something that's negative, all right? And when they added together, they got to give me a +1. So perfect, we've got x plus 3 and x minus 2, all right? X plus 3 and x minus 2, because 3 times -2 is -6. 3 minus 2 is 1, all right? And the summary for this is start with the trinomial whose leading coefficient is -1. So start with that x squared value. Okay, you're going to pull out the -1 coefficient. So then that means you factor out a -1 from each of the individual terms. Okay, then we simplify. So we pull that -1 by itself and keep the rest of it in a parentheses. And again, that should give us a trinomial that we're more comfortable with. And then we should be able to factor straight from there based on what we learned yesterday. Okay. So right here, the first step in factoring a quadratic trinomial whose leading coefficient is not 1 is to look for a common factor. All right. So we want to look for that common factor. Yay. All right. And that common factor, it's easiest for us if that common factor is the letter A, right? So an ax squared plus bx plus c. If that common factor is a, that makes it super easy for us. It gets us right back to x squared plus bx plus c. All right. How do you factor a trinomial? Right there. Okay, so this is a really, really, really good key for you, or a rule for you to be able to use. And this is what shows up in your study guides here, right? So something like this is going to show up in your study guide. So as long as you fill out that study guide, there's no reason that you need to write this down here. Okay. Now, moving forward here, it's time to practice factoring. All right, it's time to practice factoring. So this one shouldn't be, hopefully, too terribly difficult. We've got 2x squared plus 18x plus 40. Okay, they're all even numbers, and that first factor is a 2. So you should be able to pull a 2 out of everything, right? And if I multiply this back out, I've got 2x squared plus 2 times 9. That gives me 18x plus 40, right? So that one's correct. Okay. Now this one here, the leading coefficient for x squared is actually a -1. Okay. So when we pull a -1 out, all it does to the rest of the factors, it just changes their signs. But we know how to factor this guy. We don't know how to factor a negative x squared plus 10x minus 21. So you've got to pull that -1 out. All right. And this one is one I actually want to just walk you through here quickly. Okay, I want to walk you through this one so that we can talk a little bit more about it. All right. Okay, so you've got 4x squared minus 32 minus 36. Okay, so the first thing is we look for a common denominator, and our goal is hopefully it's 4. Hopefully it can be that number 4, right? So if we divide everything by 4, we actually get real numbers. So we can do this, right? So by that, I mean, I'm going to divide everything by 4, right? No, you do not have to show all of these steps, okay? So I get this might be a little excessive, but I'm doing this for explanation purposes, all right? So this ends up being 4 times by x squared, okay, minus 4 times by 8x, okay, minus 4 times by 9, right? So effectively, since I can divide everything by 4, that's what my equation turns into. Okay, that's what my equation turns into. Then I'm going to collect my 4s on the outside. Right, I'm going to collect my 4s on the outside. All right, so I've got x squared. I've got this negative sign, so I keep that negative sign, minus 8x. Keep that negative sign there, minus 9. Okay, and again, if I were to multiply this back out, I should end up with my original equation. Okay, but I've got 4x squared minus 8x minus 9. All right, so now keep that 4, and I'm going to factor the thing that I am more comfortable with, right? So I know I'm going to have x there, and the question becomes, what is my p and what is my q value, right? So I know if I were to draw that table again, okay, p, q, p plus q, all right? I've got 1 and 9, 3 and 3, and 9 and 1. Okay, those are my different combinations. Okay, those are my different combinations that are going to get me to 9. But now the difference here is one's got to be a negative. So -1, -3, and -9. Okay, but -1 plus 9 gives me 8. Okay, -3 plus 3 gives me 0, and -9 plus 1 gives me -8. Right? So therefore, this is the only combination that's going to be correct. So I'm going to have x minus 9, x plus 1. I'm going to have x minus 9 and x plus 1. So that's what I am left with. All right? And this ends up being the final answer. That ends up being the final answer for our apex. Okay? So when I write this, you've got to pay attention to the parentheses, all right? And I think that's what a lot of us might be messing up with the computer scored tests, is we're not putting in our parentheses, okay? So it should be 4. All right? And then we would have the rest of our values there, okay? So when you pull that 4 out there, okay, you would have the rest of it in the parentheses there. Okay, you would have the rest of it in the parentheses. All right. And then we would have x minus 9, right? X minus 9, and then x plus 1. Pay attention to the fact that the first one is in parentheses, right? So you have to put the parentheses. Boom, we're awesome. Okay. And there is another one here that you are welcome to try, but I know you guys have issues with the click and drag, so I don't want to spend too much time there. All right. So that is another one that you can try if you would like. And to give you a hint, obviously we're going to pull out 5, but if you notice here, it's x cubed. We don't know how to factor in x cubed. So you actually pull out 5x. You pull out 5x. So then you're left with a x here. So you've got 1x and you've got minus 12 at minus 12. All right. So when we do this, we end up with x plus 4, x minus 3. And the reason I know that is because 4 times -3 gives me -12, right? But 4 minus 3 gives me +1, which is what I'll need for this guy. All right. Moving forward here, okay, so we'll go through a couple of these problems together. Okay, we'll go through a couple of these problems together. But again, for the sake of time here, we don't have time to go over all of them. So my suggestion would be is if before you take your test, or sorry, before you take your quiz for this unit, walk yourself through quickly, refresh yourself through the notes, come to these, and then make sure you can answer these correctly, because again, they are sample quiz questions here. Okay, so let's call on Enrique, since I see that you're here now, bud. Enrique, you want to do question 1 or question 2? Vargas.
2.
2, awesome. All right, so we'll do number 2 here. Okay. And by we, I mean I'll help you through this, or I'll do it for you for the sake of time here. Okay.
Yeah.
Awesome. So, all right. So when we walk through this one here, okay, we've got negative 2x plus 6x minus 8. All right. So again, step 1 tells us to look and see if we can factor out this a value. Can all of these get divided by negative 2? Right? And the answer is yes, obviously, because they're all even numbers. So if I were to pull a negative 2 out of this first term, I would be left with x squared. Okay? If I pull a negative 2 out of this next term, I am now left with a negative 3x. I'm now left with a negative 3x. Okay? And then if I pull a negative 2 out of this last term, I'm left with a positive 4. I'm left with a positive 4. All right. So now we've got to go back and we've got to pull out that negative 2 on the outside of everything. Okay. So I am then left with x squared minus 3x. Okay. Plus 4, because that's now a positive 4. All right, so I am now left with negative 2 on my outside, and then my quadratic trinomial turns to x squared minus 3x plus 4. Okay, if I make my P and Q chart, okay, if I make my P and Q chart, I know that together they have to be multiplied to equal positive 4. But notice here, that middle one is negative. Okay, and the only way that you can have a positive here and a negative there is if both P and Q are negative. So it's either going to be negative 4, negative 1, negative 2, negative 2, or negative 1, negative 4. Okay, it's going to be negative 1, negative 4. Okay. Let me double check something here. Oh, okay. Awesome. So I'm looking at this right now. Okay, I'm looking at this right now, and none of these answers are going to work out. Okay, so none of these answers would work out. All right, and if you got to a problem like this, especially because you're doing multiple choice, you would stop there. Okay, you would stop there. You would say you can't factor any further. Okay, you can't factor that one any further. All right, and the reason you can't is because any combination of this, negative 4 minus 1, that's going to give me negative 5. Negative 2 minus 2 is going to give me negative 4. All right, so we would stop because we can't factor this any further. Right, so that would be where we would say stop, can't factor, we are done. All right, now that is not an option on Apex for this problem. Okay, and the reason that is because when I copied it over, this actually wasn't a negative 2, okay? It was actually a negative 1. But this gives us a great example to talk about cases that you just basically stop, right? And I know that that kind of is uncomfortable there, but a lot of times, like I said, you can't factor any further, right? This is what your answer is, okay? This is what the answer is for this one. All right, so we'll stop there with this problem, okay? Now, let's go with Anthony. Anthony, you want to do number 3 or we want to do number 4? Which one looks better to you?
I'll do 3.
Perfect. Okay, what am I going to factor out here, Anthony?
We're going to factor out x.
Perfect, x. So I'm left with x squared minus 3x minus 10. Okay. What combination of P and Q am I looking for here?
You're looking for negative 5 and 2.
Negative 5 and positive 2. Okay, and how did you know that?
Because negative 5 times 2 is negative 10.
Perfect.
And negative 5 plus 2 is negative 3.
There you go. Right? Perfect. There you go. We're done with this problem. okay? Not super difficult here, all right? And he didn't even need to make this chart. So if that chart is too much for you and you know off the head you can do this stuff, by all means, forego the chart, right? The chart is there for your help, all right? Perfect, good job, Anthony. Then in this last one here, you'd factor out a 3x, x squared plus 9x plus, all right, plus 14. All right. And I'm going to point out to you, I'll be very honest, I am not the best at mental math, right? So I did not know off the top of my head what 42 divided by 3 is. That's probably a problem, okay? But we live in the day and age of calculators, so I just plugged it into my calculator. So again, no shame. I would rather check something and get it right on my test by taking that little extra step to check than get something wrong because I did basic, division incorrectly here. Okay, so we would go through here. We've got 3x. We know it's going to be x and x. They're both positive, so these both have to be positive, right? And to get 14, you can multiply by 7 and by 2, okay? So 7 times 2 is 14, right? And then 7 plus 2 is 9, all right? So that would be your final answer there for number 4. All right. Any questions up to this point, peoples? Okay, awesome. So that's if there is a common factor. If there is no common factor, right? If there is no common factor, right? So if we have an a value, but we can't divide it. So, right, perfect example, 2x squared plus 3x plus 1. Okay, that leading factor is a 2. But we can't divide 3 by 2, or at least not easily. Yes, we can get fractions, but fractions aren't really easy to work with. So we can do a different thing here, all right? And this is an algebraic tile tool. Okay, I'm gonna skip over this because you don't even have the ability to do this, right? So this is showing like, okay, you'd have to put these guys and try to match them up and do stuff like this. Right? So not the easiest thing in the world to work with, okay? So we're gonna forego the tile examples for the sake of you can't even do them, all right? But basically what it's showing you is that all of these, when you add them together, you can notice I'm now getting, 2x squared plus 2x, okay? I need it to be 3x plus 1. Right? And somehow all of these are supposed to fit together and make just one rectangle, right? And what it ends up looking like is this guy, okay? So I've got x and I've got 1 and I've got x, x, and 1, all right? So again, adding these together gives me my entire quadratic, okay? Gives me my entire quadratic. But when I really look at it here, yes, this is x squared, but this column is just x by itself, right? And this column is just 1, all right? And this guy is x, this guy is x, and this guy is 1. So when we factor it, it ends up being x plus 1, okay? Because x plus 1 and 2x plus 1. All right, this is something that they came up with. But again, you don't have the ability to do this unless you're borrowing a laptop. So by all means, feel free to skip it when you're going through this. Okay, now it's showing you this, but basically you've got a couple rules here. All right, and again, this is kind of a working backwards thing. All right, in order to be able to be a factor, if you multiply the coefficients out, you should get the leading coefficient of the trinomial. So 2x multiplied by x, right? That should give you 2x squared. That's what that's saying. And then if you multiply the constants, you should get the constant from the quadratic. So if you multiply 1 by 1, you should get 1, okay? So those are two things that have to be evident, right? What's really tricky is that middle number, that 3x, okay? How do we know what that 3x is now that this first factor here is not a 1, okay? And that's what we'll work on here. So the rule is that you have it's called a reducible trinomial, okay? It means we can bring it down, all right? And it now changes. Remember, it used to just be x plus or minus p, x plus or minus q. Well, now we have rx and sx, okay? where R times by S gives us that leading coefficient, and P times by Q gives us that constant, right? So basically these rules, this is how you would say it mathematically. All right. And I have that on my notes so I can show you what that looks like to me. All right. But looking at our examples here, what this is saying is 3 times by 2 has to give me 6. Okay. And 5 times by 1 has to give me that 5 constant. Okay. It has to work out like that. All right. And we'll figure out in the next couple of slides, well, how did you know to put 5 here and 1 there? Right. And that's how we're going to get that middle value. Okay. Because obviously 3 times 1 gives us 3x, and 5 times 2 gives us 10x. Okay, so that would give us that 13. But if we were to flip these, this would be 3 times 5, which would be 15, which would be way too much, right? So we'll talk about how we know where to put what. Okay, looking at another example here, we've got 9. Okay, so 9's kind of easy. It's either 9 and 1 or 3 and 3, right? And it's easier for us, so we go 3x and 3x. Okay, and now we know it's got negative 20. Okay, so 4 and negative 5 would give me negative 20. And again, how did I know it's negative versus positive and which direction? That's what we're going to work on in the next couple of slides here. Okay, so factoring a trinomial, okay, in the form, you begin by making your list of P's and Q's. Okay, so that's very, very similar. Okay, but now we add on an extra step here. We now have to look at the leading coefficient, or that A value. Okay, so you can make a table for your leading coefficients, and you can make a table for your constants. Okay, you can make a table for your leading coefficients, and you can make a table for your constants. So I might have 8 and 1, 2 and 4, 4 and 2, 1 and 8, right? And that's all the combinations that could possibly give me 8 there. And then for 4, any combination of P and Q. So 4 and 1, 2 and 2, or 1 and 4. All right, and what this wants you to show is typing in different combinations. Okay, you're just going to use the FOIL method, right? So they're saying, okay, put in a combination of R and S. So if I put R there and S there, okay, so R was 8, S was 1, and I put in, let's go with 2 and 2. If I expand it, that one's wrong. Okay, if I expand it, that one's wrong. But if I go with, let's go with 4 and 1 here, that one's going to be correct. Okay, and again, a lot of this could be trial and error. But there are, for this one, there was multiple ways to get this correct. Okay, so I used 8 and 1. Okay, they're showing you 4 and 2. Okay, and they're showing you 4 and 2. And even with the 4 and 2, it was plus 4 plus 1. And this one became 2x plus 2 and 4x plus 2. Okay, so there's multiple ways of doing this. But if there are multiple ways, it can be factored even further. All right, so what that means is 4x plus 4, you could pull a 4 out of that little quantity. Okay, you could pull a 4 out of that quantity, and that would give you 4 times by x plus 1 times by 2x plus 1. Or if we looked at this second factorization, okay, okay, you had 2x plus 2. Well, you can pull a 2 out of that one. All right, and then you had 4x plus 2. You could still pull a 2 out of that one. All right, and then when you combine your like terms, you've got 2 multiplied by 2. Pull that out, that gives you 4. All right, and so same thing, even if we did the one that I picked 8 and 1, I can still pull a 4 out of there, right? I can still pull a 4 out of that first one. So I was going to end up with 2x plus 1 and x plus 1. Okay, in the last 2 examples, the signs of the trinomials were all positive. Okay, they were all positive, and we know that's not always the case. So when we pick the correct combination of the factors, sometimes it takes a little trial and error, right? So negative 15x, if the leading coefficient is negative, you're going to pull out a negative 1. Okay, you'd pull out a negative 1. But then we look, obviously we can't divide this first one by 15, so we're kind of stuck there. All right, same thing here, we pull out our negative 1, but 3 doesn't divide evenly into the rest of them. So that's kind of trick number 1 there. okay? If the sign before the constant term is positive, right? So if this is positive, okay, then they both have to have the same sign, right? Because two positives multiplied together give you a positive, or two negatives multiplied together give you a negative, right? So positive, positive gives you two positives. Negative, positive gives you two negatives. All right, and then that third tip is if the constant sign is negative, then they've got to have opposite signs. So one's got to be a positive and one's got to be a negative. That's the only way you can multiply two numbers together to get a negative number. All right. So rather than doing this here through the factoring tool, because I know you guys can do this and click and try later, I'm going to show you what this looks like when you should write this down on like paper or your iPad here. Okay, so that first example here, oh, let me scroll back up. So the general rules for this is if there's no common factors, right? AX squared plus BX plus C, if there's no way to divide out A from everything, you then change your equation to RX plus or minus P multiplied by SX plus or minus Q, right? Where R times S gives you our leading coefficient of A. Okay, so R times by S has to give us A, and P times by Q still has to give us C. Okay, so when we're doing this, okay, and again, for the sake of time, I'm going to go through this quicker. Okay, 2x squared plus 3x plus 1. I cannot divide out 2 by anything. Okay, so my A term here is 2. All right, so for R and S, there's only two combinations. It can either be 1 and 2 or 2 and 1. All right, that's the only combinations I can get here. All right, then for the C term, for my C term here, for P and Q to get to 1, obviously it's only 1 and 1. Okay, so then the last thing here is, right, I've got 2x and I've got x, and I know it's going to be plus 1 and plus 1. Okay, and this one wasn't super difficult because they're both the same number here. But if they're not the same number, you'd have to decide which one's going to give you, added together, that combination of 3x. Okay, so the next problem here, okay, is able to be divided by a number. So we can actually pull 4 out of all of this. Okay, so when I simplify here, I've got 2x squared plus 3x plus 1. Okay, so I pull 4 out, and lo and behold, it's the same problem as above. It's the same problem as above. I just pulled 4 out. Okay, so this turns into 4 times by 2x plus 1, x plus 1. Okay, so again, it's all about finding, if you can pull something out of the entire quadratic, do it. Makes your life easier. If you can't, then we've got to look at R and S and P and Q. Okay. Moving forward here. Okay. When factoring any quadratic trinomial, first look for a common factor in each term, right? Once we find that, we have different steps. You've got rule 1, which is factoring any quadratic trinomial. You'll look for the factor, factor it out, and then find the simplest version if we need it, okay? And then your rules for choosing signs. Again, it's all based on starting with what sign is for your constant, okay? If your constant has a positive sign, they're both going to be the same. If it has a negative sign, one's got to be positive and one's got to be negative. Okay. We're gonna skip this one for the sake of time so we can focus more here on your quiz questions. Okay, on your quiz questions. So I've got 4x plus 1 and 3x plus 2. So if I go to my iPad here, it's just asking us to, okay, it's asking us to multiply this out. It says the expression below gives the factors of what trinomial. So you would just follow the FOIL method, first, outer, inner, last. You would do 4x times by 3x plus 4x times by 2 plus 1 times by 3x plus 1 times 2. Okay, so you would execute this, you would combine like terms, and then you'd get your following expression. Okay, so this one shouldn't be anything different. Okay, the one that might be a little bit more difficult here is this next one. So you still have to FOIL first, outer, inner, last. Okay, so you still FOIL, right? I end up with 5x squared. I end up with 5x squared as my first term, and then I get plus x minus 20x minus 4. So 5x squared minus 19x minus 4. But we can't forget that we still have a -1 on the outside here. We have a -1 on the outside. All right, so what we have to do is we have to carry that -1 sign. So it now becomes -5x squared plus 19x plus 4. All right, so that's how we would get to the following trinomial. All right, and then we have two problems here, and for the sake of time, I'll just pick one. All right, so the first step for this guy would be to pull out 4, right? 4x cubed plus, oh, sorry, we can't pull out a 4. I lied to you. We can only pull out a 2. So this ends up being 2x cubed plus 3x squared minus 9x, right? And when I look at this here, I've got x cubed, x squared, and x. So I can even take this one step further and pull out an x value. Okay, so then from there, we should be able to factor, right? We should be able to factor. So we know that r times by s has to give us 2, and we know that p times by q has to give us -9. All right. All right. So again, when you're going through this, you should be able to hit refresh and go through. Like I said, my suggestion personally would be to walk yourself through the entire study. Okay, we've talked through it. Walk yourself through. If you're able to do the little click and drags or the activities and you want to check yourself, by all means, great. But bare minimum, I'm talking bare minimum. You need to go through the study and you need to come back to this slide here. Okay, you need to check your understanding, because if you can do these 4 problems, then you're good to go to work on our next, you're good to go and take your quiz here. But if you're struggling with these, figure out where you're struggling, go back in the study and relearn that. Okay. And then obviously we have our study guide here. All right, so I will post the answers to the study guide per usual. All right, but if I walk you through this quickly, the lesson is not about this lesson is about factoring quadratic trinomials where a is not 1, right? The coefficient is not 1. The first step is to look for a common factor. All right, we only factor out -1 when a is negative. All right, we don't take something that's positive and then make it negative. All right, so how to factor with a common factor. These are the steps that we walked through in general, okay? The right side here is actually working you through a problem, okay? So again, you pull out the common factor of 4. So we've got 4 times by x squared plus bx plus c, all right? Then we factor with our p's and our q's, right? So you take it now to 5 and 1, all right? Now, if it's ax squared plus bx and we can't reduce it any further, right? We can't reduce it any further, okay? We have to look at r times by s has to equal a. So example, 3 times by 2 has to give us 6, okay? And then it says p times by q equals c. So p times by q, so 5 times by 1 has to give us 5 there. All right, so again, this is just a really, really good thing that I would suggest having out with you when you go through to take your test. Okay, again, so this is walking you through leading coefficients, constant terms, right? And then figuring out the guess and check, right? And I know it's not everybody's favorite, but if you're stuck, just try both of the combinations, right? Try both of the combinations. So you've got 1 and 3 and 1 and 2. Then you tried 3 and 1 and 1 and 2. So then the next one would be 1 and 3 and 2 and 1, right? It would be 1 and 3 and 2 and 1. Then it would be 3 and 1, 2 and 1, right? I know this one is 4 here, okay? But if you do this a couple times through the guess and check method, you should be getting more comfortable to figure out which one's actually correct, okay? And as you see here, when you guess and check, you found out that this is the right answer on the second one. So you don't need to keep going any further, okay? So if we were to do all of this, those would be all 4 of your combinations. But basically, once you get to the right combination, you stop doing the rest of it, okay? Write the factorization of this one. So again, this is figuring out what your R and your S is, what your P and your Q is, all right? And then this is the quick thing. If A is negative, you're going to factor out a -1. If C is positive, right? If C is positive, they both have the same signs. And if C is negative, they have different signs, okay? So again, when you're going through this, either go straight to the answers here and make sure you understand it, or you can walk yourself through that guide, all right? Okay. For your checkup here, I actually have this one, I have this one shared out on my Notability. And what I will do is later on today, I will release a video here for the sake of time where I walk through a couple select problems, right? So I have number 1, number 4, and number 6 highlighted. I'll walk through number 8 and number 9. Okay, and what this will just do is if you're someone, when you're going through, if this is making sense to you, or you're rocking and rolling, or you've already done this, right, you don't have to go back through and watch this. But if you're struggling to understand how do we get to the answers, right, I will walk you through that. Okay, because I know you have the ability to look at this and do it, but sometimes it's more helpful if you have a little bit of audio. So I'll make sure I post a video for that a little bit later today. Okay. So you have both of the answer keys. You will have both of the answer keys for this unit here. All right. And then for this one here, you have both quizzes. Okay, so you have both of these quizzes you will need to do, okay? This first one here is basics, right? So it's talking about if you can pull out A from everything. All right, this next one here is a little bit more advanced. So if you can't pull A out, or if you've got to pull a negative value, right? It's that more advanced stuff. Okay. So then for this one here, okay, looking at it, we are not doing the journal, okay? And I'll release the schedule, but we are not doing that journal. Okay. For 3.3, moving forward here, we're talking about special cases. All right, so special cases. This is if we have something a little bit special, a little bit easier, right? These are the things that are like tips and tricks. Okay, so we have perfect squares versus perfect cubes. And I will just share with you my iPad of what the notes I made for this one is. Okay, so we have perfect squares. So a perfect squared is something like A squared, where A can be a number or a variable. So for example, 3 squared equals 9. That's a perfect square. Or X squared, because I've got X multiplied by X. That would be a perfect square. Now a perfect cube would be something like 3 cubed, which is 3 times 3 times 3, which gives me 27. So that's a perfect cube. So 27 is a perfect cube, or 3 cubed is a perfect cube. Same thing, if I go with X, it's now X cubed, right? It is now X cubed. So that apex there wants to walk through perfect cubes and not perfect cubes, all right? So an example of a not perfect cube would be like 121, okay? Because 121 is 11 squared. So that would be a perfect square, but not a perfect cube. All right. If we keep moving forward with this, there are multiple quizzes in this one. There are multiple quizzes. So what I tried to do is I tried to highlight which quiz is going to talk about which section, because before you take your quiz, if you just want to review that small little part, you can do that. So for example, we're going to talk about difference of squares, and that is going to be the first quiz that you come up to. So the first quiz is all about just the difference of squares. All right, just the difference of squares. So if we look at Apex, okay, right there it says difference of squares, okay? So your first quiz is all about this, okay, and only this. So if you go back, it starts on slide 2, right? You can walk through the couple of slides here and see if you get what's going down. Then you can go take that specific quiz, right? Then you can go to the next section, review that, and keep rolling. Okay, so if we take a look at x squared minus 9, you noticed x squared is a perfect term and 9 is a perfect square, right? Because like we said, x times by x gives me x squared, and 3 times by 3 gives me 9. All right, and the calculator way, or I guess you could call it the cheater way of figuring out if it is a perfect square, okay, if it is a perfect square, you go to your calculator, right? Which you should now all have a scientific calculator. Okay, you type in square root. You type in square root, and what that looks like on your calculator. Sorry, let me share. What that looks like on your calculator is the button that looks like this. Okay, it looks like that. For me, in order to do it, I have to hit my second button, and then I have to hit my button that says x squared. Okay, for me, it is a blue button. But you hit this, you type in square root of 9. When I hit enter, it gives me a whole number. It gives me 3. Therefore, I know that 9 is a perfect square because basically 3 squared gives me 9. All right. Now, something that would not be a perfect squared would be square root of 11. When I type this into my calculator, it gives me 3.3 whatever. Okay. If it is not a whole number by itself, it is 3 point something. This is not a perfect square. It is not perfect. Okay. It is not perfect. So that is a way to figure out really quick and easy what's perfect squares and what's not. Okay, so again, we can look at this. It's a specific one. It's called difference of squares. All right, difference of squares. And basically what this looks like here, it's still a polynomial, right? It's got multiple things, and it still has that x squared value. So it is still under the quadratics because it has x squared. All right, and what we can do is we can factor it in a very special way. So basically, right, x squared minus 16, we can look at that one in particular. So if I share my iPad with you guys. Nope, there we go. Okay, so if we look at x squared minus 16, this is saying, okay, well, I know this one is x squared minus 16. If I type into my calculator, if I don't know off the top of my head, square root of 16, that gives me 4. So this is like saying 4 squared. All right, so it's like saying 4 squared. And then what I can do is again, you can like collect those like terms. So basically what I'm saying is you can go x minus 4 and put the squared on the outside, right? That's your factoring tool there. That is your factoring tool, okay? Because basically, if I do x minus 4, it's the same thing as x minus 4 squared. You've got that quantity twice. All right, if we go to, let's go to the next one, x squared minus 4. Again, it's like saying x squared minus, well, 4 is 2 squared. 2 times 2 gives me 4. So I can either say x minus 2 times by x minus 2 or x minus 2 squared. All right, and again, you can go through these other 2 problems and use that factoring tool on Apex, okay? And if you want to double check me here, for that first one, we said x minus 4 and x minus 4. So I've got x minus 4, right? And there we go. So now we noticed there's a problem. Okay, there's a problem, and we'll work through that, right? So there's a problem here. If I type that in, it's x squared minus 4x. So what the heck happened? Oh, well, one, I didn't type that in. But, okay, when I type that in, okay, I've got the 16, but it's now positive, and now I've got this other factor here, right? And we'll talk about this in the next couple of slides here. But what we didn't consider is that one of these has to be positive and one of these has to be negative, right? One of them has to be positive and one of them has to be negative, because how else did we get the negative sign? Oh, dun, dun, dun. All right, so then this one says, if I have x minus a and x plus a, why does it not contain an x item? So why is it only x squared, and why is there not that x factor in the middle? And the reason that is because if I have the FOIL method and I FOIL this guy out, I've got x squared minus 4x plus 4x minus 16, right? So by having one of these positive and one of these negative, and then being the same term, they cancel each other out. So I have no x to the power of 1 term. All right, so perfect, right? So if we go through this, right, the same thing for the last one. I have to have an x plus 2 and an x minus 2. All right, I've got to have an x plus 2 and an x minus 2. All right, and the really basic form, or the simple form for this, is if I have x squared minus b squared, and b just means it has to be a number, right? So x squared minus 25, okay? I know that x is can be written as x squared, right? And then I know 25 can be written as 5 squared. So what this factors in as is x squared minus b squared equals x plus b, x minus b, right? So we slightly evolve our equations from earlier, right? So now it has to be, take out that middle part, right? We know one of these has to be positive and one of these has to be negative, right? So if this is saying x squared minus 5 squared, okay, we now know that we have to have x plus 5 and x minus 5, right? Same thing. This value here is x squared minus 1, technically squared. So we now know that we have to have a plus term and a minus term. All right, and there is a basic form for this, right? So we can now look at things just generally. So if I have a squared minus b squared, it can always be factored as a plus b, a minus b, right? Where a can be a number or a variable. Same thing, b can be a number or a variable, right? So knowing this, if I say a, okay, so a has to equal x, because this first one here is x squared. B here is going to be 9, because 9 squared gives me 81. 9 times 9 is 81. Or again, you plug into your calculator, square root of 81. You hit equal sign, that's going to give you a 9. All right, so now that I know this, I can use this formula here, and every time I'm going to have a plus b multiplied by a minus b. So x plus 9 multiplied by x minus 9. Okay, hopefully pretty simple here. Hopefully pretty simple. Now, it gets slightly difficult here when we have a coefficient that's not 1. We have a coefficient that's not 1. But if, again, you don't know this off the top of your head, square root of 36 is 6. So square root of 36 equals 6. Square root of x squared equals x. So this first term is actually like saying 6x squared, because when that squared is on the outside of the parentheses, you have to distribute to both, right? So it's like saying that. Okay, but for simplicity's sake, we just keep it as we see it here. All right, And obviously, as we said, square root of 9 equals 3. So I've got 3 squared. Okay, so the formula doesn't change. It's still a plus b, but now your a is 6x. Okay, so now I have 6x plus 3, 6x minus 3. All right, so now I have just something where it's not just x by itself, but we still follow the same pattern and follow the same principle. Okay, and this is personally the hardest one I think you will see. Okay, this is the hardest one I think you should see through this. Okay, so again, we still have a squared minus b squared, right? So this is my a squared, this is my b squared, but I have to figure out what the heck is a by itself and what the heck is b by itself. So a by itself, if I look at just a to the fourth, okay, it's a squared. Okay, it's a squared, because when we're looking at values, if I take the square root, it's like saying dividing this by 2. So when I look at a to the fourth, if I take the square root of that, it's like saying a4 divided by 2, which gives me a squared. Okay, and that's something you should have learned in like algebra 1. So if this is new, I'm sorry. Okay, but you should just know that all you have to do is divide the exponent by 2. All right, so a is a squared, and b squared gives us b, right? Because if I have b squared divided by 2, 2 divided by 2 is still b to the first, or just b, right? So my a value there is a squared b, and my capital B value here is m, because 2 divided by 2 is 1, and then 6 divided by 2 gives me n to the third. Okay, gives me n to the third. So my final equation is still going to be a plus b, but it's going to look a little bit different. A squared b plus b, which is mn cubed, a squared b minus mn cubed. Okay, and I know it's really uncomfortable when we're dealing with a lot of variables, which is why I wanted to walk through this problem with you. Okay, and then last one that we'll do with this guy. Okay, so the square root of 16 is 4. The square root of x is x, or sorry, x squared is x, right? So basically that's like saying 4x squared, because 4 times 4 is 16. Same thing, I've got 25, so that's like saying 5 squared, and then I've got y squared, so it's 5y squared. All right, your final answer for this guy is 4x plus 5y times by 4x minus 5y. All right, and again, if you're ever stuck, remember square root of your number should give you a whole number. If it gives you any decimal places, it's not a perfect square. It's not a perfect square. All right, and then always the last step you can do is you can always refoil this back out, and if you do it correctly, you should get your original back. Okay, you should get your original back if you do this correctly. All right, so let's bring it back to Apex here so we can keep rolling. Oh, nope, wrong one. Sorry. All right, so bringing it back to Apex here, they're going to walk you through those notes that I just walked you through quickly. All right, so factoring here, you're going to have these examples. So we just walked through a couple of these, but 81 squared, or sorry, 81, the square root of that is 9, right? So 9 squared gives you 81, okay? So that's an example where they're both numbers. This is an example where one's a variable, one's a number. Here's an example where you've got something a little bit more involved, right? So it's not just 1x squared, now it's 4x squared. And then you've got something that, again, like I said, is probably the hardest ones you'll see is only variables, okay? But you're still going to use that rule. You got to figure out what capital A and capital B is, and then you just plug it right into that equation. You plug it right into that equation. Okay? So, again, you can check the difference of squares, multiply it back out, and you should get the original. This is showing you a picture of what this might look like, right? So if I go back, this is showing you that if you have a squared, you take away b squared. If you rearrange it, it was a squared minus b squared, right? And that's what this picture is showing you. Okay, so 4x squared minus 9 is an example of difference of squares. Okay, it's an example of difference of squares. And we are specifically having a single quiz on difference of squares. So if I can open this back up here. Okay, we are having a quiz in this unit. Oh, of course, return to the home page. All right, we're having a quiz on just difference of squares. Sorry. So you'll have one quiz on just this difference of squares. So when you get to this page here, right, when you get to this check your understanding page, if you can do these 4 problems here, you're great to go on this difference of squares quiz here. All right, so to remind you, that would be quiz 3.2.3 or just the first quiz. All right, now we have the next little unit or mini unit in this is on perfect square trinomials. Okay, it's on perfect square trinomials. And this would be your second quiz. Okay, this would be your second quiz. And what this is going to look like here is if you now go from just having a squared minus b squared, we have a couple of different things. So we now know how to factor difference of squares, right? We can factor difference of squares, but we're going to try to figure out a couple specific cases, right? So I kind of prequeled those for you. If I have x plus 3 squared, okay, if I factor that out, it's like looking at x plus 3, which would give me this perfect example here. All right, so looking at this, right, here's how that would break down. If I factored this our normal way, I'd have x plus 1 and x plus 1. Well, that could be simplified as x plus 1 squared, okay? For this guy, I have 2x, right? 2x plus 3 and 2x plus 3. When I FOIL it back out, I get this original here, but these are the exact same, so I can just write it as 2x plus 3 squared, okay? Same thing here, same thing there, all right? And this is called a perfect square trinomial. Perfect square trinomial. So now we're not just doing the binomials where it was a squared minus b squared. We are now doing if it's a full trinomial. Okay. So looking at this next one here, okay, you can have it be either a plus b squared or a minus b squared. All right. And it's going to give you these general equations when you expand them out. So if you were to start with something, it's going to look like a squared plus 2ab plus b squared, right? And what does that mean, right? We'll talk about that. But basically, with these examples, factors of perfect square trinomials, okay, it's going to reduce down to a plus b squared or a minus b squared. Okay, so in a perfect square trinomial, the first and the third terms have to be perfect squares. So the first and the third terms have to be perfect squared. So what does that mean? Right here, x squared is a perfect square, and so is 36. Okay, that gives me that gives me x squared, and that gives me 6 squared to get 36. Okay, so that's how I know it's this guy. Same thing here. I've got x to the 8th, okay? And if I divide that by 2, that gives me that gives me x4, okay? That gives me x4. And 64, okay, 64 is a perfect square, and it's actually the number 8. But what we're going to talk about here is again, this is a negative sign, so we've got to make sure that we've got the correct sign there. It's got to be a -8 and not a +8. So the first and the third terms are perfect squares here. All right. Now, here's the properties that make a perfect square trinomial, right? First and third terms have to be perfect squares. Neither the perfect squares can have a minus in front of it. So A has to be positive, C has to be positive, all right? And then if the perfect square terms are a squared and b squared, then the other term has to be a 2ab. All right. So example, you've got a squared is x squared, b squared is 9. All right. Or 4x squared and 25. Okay. But the difference is if it's plus versus minus. Okay. Neither of the perfect squares can have a negative sign. So if this was negative 49, this wouldn't work out. This wouldn't work out because there's no way that you can square a number and get a negative number. Okay. And then property 3 here. Okay. So I've got 9 and x. So when I have that middle term, it's got to be both of those multiplied together. So 18x. I've got 2x and 5 as my squares. And then multiply those together, it has to give me 20x. So those are my 3 properties here. Now, how do we actually work those backwards? How do we work those backwards? All right. Again, you figure out the perfect squares. You figure out the perfect squares, and then we should be able to roll from there. So if we look at those 4 examples here, okay, again, we'll do maybe 1 or 2 of them, and then they have that factoring tool. They have that factoring tool there for you so you can do a quick check without having me there. All right. So if I look here, this first term is x squared by itself. That's fine. This is positive. That's another rule. And 36 is just like saying 6 squared. Okay. So that's perfect. Now the only difference here is now I have a negative sign. So this has got to be negative 6 squared. Right? And I can go through all the P's and the Q's, but again, we can skip that and go quickly because we now know difference of squares. So this is like saying x minus 6 and x minus 6. Because if I were to actually FOIL this out, 6 plus 6, oh gosh. 6 plus 6 gives me 12. So that's P plus Q gives me 12. And P times by Q is 36, right? So this is how this one works out. And we can simplify this even further, combine them and put a square there. Okay, combine them and put a square there. All right. Same thing here. Same thing here. Again, we could go through the A terms, we could go through the C terms, or we can just know that 9 is a perfect square, right? 9 is a perfect square because it's 3 squared, and x squared is a perfect square, right? So this is my A value. My B value, or my capital B value, is 5 squared. Okay, so when I'm doing my factorial, I've got to have 3x minus 5 and 3x minus 5. All right, and then we got to check the middle. Okay, so it's plus 30x. Okay, so since it's a positive in the middle, we know that both of those are now positive. All right, and if we want to check, we have to make sure that 30x is gonna be realistic. Okay, it's got to be 2 times AB, or 2 times by 3x times by 5. So 3x times by 5 is 15. So 2 times 15x gives me 30x, right? So this one works out here. Okay. If we go back to Apex here. All right. Now, again, those are ways to show you all 4 of the factorizations. So again, please go back and feel free to work through those problems yourself, okay, if this isn't making sense to you. Now, again, we're going to skip these algebraic tiles, but basically what you're going to notice here is if we did something like this, it would be like saying x plus 5, x plus 5, right? And when we multiply all that out, it gives us this x squared plus 10x plus 25, right? Because of how it works out with the perfect squares, all right? But we'll skip those for the sake of time here. All right. And something that's not immediate obvious is if there's a perfect square in an expression. Okay. If we've got these in expressions. So to quickly go through this one for you. All right. So what this ends up looking like, again, remember, we can take an exponent, and if we divide it by 2, this would be the square. So this is x squared gives me x to the 4th. Okay, so what it's saying is it might not be totally obvious that this has a square to it. But if we rewrite it the way that I just showed it to you, we get x squared minus y squared, right? So that looks like x squared minus b squared. So we can solve the problem from there. Okay, I mean, same thing here with 4x to the 4th. Okay, we know that 2 is a perfect square, but x to the 4th, if we divide that by 2, gives us x squared. So if we were to say x squared, that would give us x to the 4th, right? Minus 3 squared. So again, now you have your a squared minus b squared. Okay, and this one here is the last problem I'll walk through with you guys. Okay, this one is not super obvious, except for, look, they both have x values. So we just pull what we learned originally. You pull that x out. We've now got x squared minus y squared, or x times a squared minus b squared, right? So we can still do that process. We can still do that process and simplify it from there. Okay. All right, now if we review this here, perfect squares, okay, perfect squares. The factor of a perfect square trinomial are identical binomials, okay? Basically saying, remember, it's got to be 2 of the same thing. So you've got to have, you know, x minus 2, x minus 2. Those are identical binomials. Okay, and perfect square trinomials, what they end up looking like is you've got a squared either plus or minus 2ab plus b squared. But the process for that, like we said, is a squared's got to be, or sorry, that first term's got to be a perfect square. The last term's got to be a perfect square, right? And then we can figure out what those are by saying a plus b squared. And then depending on if that middle sign is positive or negative is going to tell you if your factorization is positive or negative. Okay, so again, here's more practice that you guys can hopefully work through here. But again, if I look at the first and the last term, that's what I'm looking at here. So I know that that first term is going to be x by itself. Right? And then 144, if I plug into my calculator, square root of 144, that's going to be 12, right? It's going to be 12. And then the last thing we would have to figure out is it going to be a plus or a minus? And it's going to be a plus sign because both of these are positive, all right? They're both positive, right? And to walk through one more of this, okay? 36, like we said, 36 is 6 squared, and I've got x squared. So this first term is 6x. And then look, notice it's a minus sign because there's a minus there. All right. The square root of 4 is 2. So I end up with 6x minus 2. And then that whole thing is squared. All right. Now, again, I'm going to let you guys do this one on your own here. And this is, again, when you get to this stopping point, this is your second quiz. Okay, this is your second quiz. It is all on. It is all on. The title of it is Perfect Square Trinomials. Perfect Square Trinomials. Okay, and I know I'm running out of time here, so I want to just try to finish this last section up here quickly. Okay, this last one here is sum of cubes. Sum of cubes, sum and difference, okay, of 2 cubes. All right, so now it's basically the same thing, except for instead of saying a squared plus b squared, we're saying a cubed, or a to the power of 3 and b to the power of 3, okay? So here's some examples. You've got x cubed plus 8, right? And 8 is a cubed because it is 2 times 2 times 2. All right. And if we walk through the steps of how to do this here, okay, you can factor this large thing out into just a squared plus b, or sorry, a cubed plus b cubed. right? And what this is going to do is it's going to show you, okay, if we start with a factorization and we distribute again, and we group like terms, and then we simplify, right? If we take this whole thing out and just multiply it, right, distribute, combine like terms, it ends up with this really simple a cubed plus b cubed. It ends up with a cubed plus b cubed. So again, that's really, really simple. So then when we're looking at this guy, the only difference here is that we went from a plus b, so now we're looking at a cubed minus b cubed. But again, you still start with the factorization. We walk through it, we distribute again. We group like terms. And then when we simplify, it ends up giving us just a cubed minus b cubed. All right, so I'll walk you through a couple examples here, but this mini section is mini, right? I mean, it's mini for a reason here. Okay, so again, here's what your rules end up looking like, and this is your third quiz. So you have a third quiz just on sum or difference of cubes. So again, personal preference. I would suggest that you go through, look at these mini sections, and then once you're comfortable with that mini section, go take the quiz. Come back, finish the next mini section, take that quiz. And that's going to be my recommendation moving forward, since there are multiple quizzes for this. All right, but again, in my opinion, that makes it better for you guys because you're now doing multiple quizzes. So you have multiple opportunities for points, and they're broken up. So it's asking you to focus on one specific thing. So for this one, it's sum or difference of cubes only. Right? So again, this is what those general things look like. But basically what we can do here is, if I'm given this equation, x cubed plus 27, okay, I can figure out this is going to be a cubed plus b cubed, right? And this ends up being x, and this ends up being 3. And how did I know that, right? So for x cubed, if we're going to try to figure out what it's cubed, we divide by 3. So 3 divided by 3 gives me 1. And the last part here is 27, okay? So if we were looking at the square root, we would type in this guy, and it wouldn't work out for us. The square root of 27 is not a nice number. It ends up being 5.19, blah, 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 okay? But what this looks like actually is you now put a 3 there. Okay, and I'm going to walk you through how to get this on your calculator if you need it. Okay, so on most calculators here, you should have a math button. Okay, you should have a math button. All right, so you hit the math button. And then for me, on the fourth option down, it literally looks like this. It has a 3 cube and a brace. So you hit that button. You hit that. And if I scroll down here, I hit that. And then it takes me back to my main screen, where then I just plug in 27. Okay? And when you plug that in, you get 3. Right? That would be how you could do this on your calculator. Another way you could do this, if you really wanted to, is you could type into Google. You could type into Google, what is the cubed root of 27? Cubed root of 27. It will tell you it is 3, right? So you have 2 options for doing this. My personal preference, figure out how to start using your calculators. But if the calculator is new and scary and you don't know how to work it, okay, you can always go to Google. Type in cubed root of 27. Okay, you can type in cubed root of 27. All right, and I know I'm running out of time here, so I do apologize, but I just want to walk you through here real quickly. So that would be how we get this guy. All right, and then the last step here, the last step is we figured out what A is and we figured out what B is. And we know that we're dealing with A plus B. So now all you do is you come in and you fill in that equation. So I know A is X. I know B is 3. I know A is X, then it's squared. Minus A plus B. So 3 times X, or X times by 3, plus 3 squared. Okay, you plug in, and then you simplify. You plug in, then you simplify. So X plus 3 can't go down any simpler. We already simplified X squared. I guess I should have put it like that, but X squared minus 3X plus 3 times 3 gives me 9. So that would be how you solve for that guy. Okay, that would be how you solve for that guy. All right, and there are more problems here, okay? But I don't want to take up too much more time. I've already run 5 minutes over, so I'll go through maybe one more problem here, okay? This guy might be one of the most complicated that you'll see here. All right, so again, if you don't know, you can type in cubed root of 8 equals, that's going to give you 2, right? And then if I were to do that for x cubed, it would give me x. But I don't suggest you typing that in on your calculator. Okay? So this first value here, I've got a cubed plus, a cubed plus b cubed. All right? So my a value, if I dissect 8x cubed, that gives me 2x. If I dissect my b value here, the cubed root of 27 is still 3. All right, and I've got 3, and then y cubed is just y. Right? So then I follow the same thing. I plug into the equation. All right, and that looked like this, right? A plus b, dot, 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 dot. I believe that was maybe minus, right? Okay, you plug into the equation. You execute, and you simplify. And that would be how we do this, okay? And we're going to mostly work in this direction, okay? So that's what it's going to ask you here moving forward. It's going to work you in that direction, all right? Okay, so again, on Apex, just to quickly go through the last couple of slides here, you should be able to click on these guys, right? And they'll turn around the tiles. All right, so again, you've got a cubed plus b cubed, so it's going to be this equation. So once you figure out what a is and what b is, all you got to do, figure out a, figure out b, plug in and simplify. All right, this one is a minus, right? So you get a cubed minus b cubed. You got to figure out what a is, you got to figure out what b is. But once you do that, all you do is you plug in and simplify. Okay, so then here, again, these are for you to go through. These are for you to go through. But I want to show you one quick thing here. So we just did this last problem. Okay, we just did this last problem. If you have an exponent, okay, so if you have an exponent, you're going to use that caret button, that uppercase arrow. So if I were to write this original equation, this would look like 8x caret cubed. Okay, so that's me saying 8x cubed, 8x to the third, plus 27y caret 3. Okay, so I just wrote out in mathematic terms for the computer to understand what this is going to look like. Okay, so then when we go to type in our final answer here, so since this one was multiply, we're going to multiply. I've got 2x plus 3y. Okay, you got to notice I'm putting in parentheses, and I'm being very, very specific about the parentheses. Okay, and again, I think a couple of us maybe messed this up here in the beginning. But I can't type in, so the next part was 2x squared, right? I can't type that in. I've got to actually execute that because 2x squared turns into 4x squared because we take the 2 and we square that, right? So you've got to make sure that you actually simplify that guy down, right? And again, just for full clarity, I know I've ran over 10 minutes, but I appreciate you all staying here with me. I want to make sure that you do well on your test here. Okay? So again, it's, and I'll pull the general equation. All right? So I've got a cubed plus y cubed. A cubed plus b cubed or plus y, right? So I know what my a and my b values are. So again, you have to plug in. So next step is 2x plus 3y times by a squared. So I've got 2x squared minus a times b. So 2x times by 3y plus my b squared. So 3y squared. All right. You cannot type this in. You cannot type this in as your final answer. You have to get it down to the simplest form. So when we actually execute this, 2x plus 3y, right? You got to distribute that square. So 2 squared is 4, x squared is x squared. So quantity 2x squared now becomes 4x squared. Okay? Minus 2 times 3 gives me 6xy. And then I've got to distribute that squared. So 3 squared gives me 9y squared. Okay, so that would be what you plug in. That would be what you plug in. And again, just to re-walk you through, because I know I had a couple people ask me this question. It looks like 4x caret 2. That says x is to the power of 2. Minus 6xy plus 9y caret 2. Close your parentheses. Okay? So again, formatting is unfortunately very important, okay, when we're using the computer programs. All right, submit, perfect. All right, so again, that's to ensure that you guys can type these in and be awesome rock stars like I know you are. All right, study guide here. This one is rather long, so I'll let you go through it on your own, okay, but there are 3 different cases. So again, there's a quiz on difference of squares. There's a quiz on perfect square trinomials. And there is a quiz on, where is it? And there is a quiz on the last one there, which was titled, trying to find it for you. Factoring cubes, right? Difference of cubes. All right. So again, go back through, look through the answers, okay? Go through it, your different sections if you want. Yes, awesome. Okay, so again, you've got 3 different quizzes and you click on it, right? This one says factoring a difference of squares, factoring perfect square trinomials, and then sum or difference of 2 cubes. Okay, so those are your 3 different quizzes here. All right, and I broke them down for you where those sections start and end. All right, your journal is extra credit. Okay, if you want to do it, it's extra credit, but I don't suggest or I don't recommend, you don't have to do it if you don't want to, okay? If you're nervous about your grade or if you want extra practice, by all means, or if you already did it, congratulations. But you've got 3 quizzes here and that is more than enough of work for you to do. So please don't feel like you have to do this, okay? Later on, since we ran a little bit over, later on I'll post a video for lesson 3.4 and lesson 3.5, okay? So those are the ones that you're kind of expected to cover today, right? With your 3 hours, all right? You're expected to cover those today, and then over the weekend, I will have videos for 3.6, 3.7, 3.8, 3.9, and 3.10. Okay, so you'll have to cover those over the weekend. And again, it's hopefully a little bit easier for you guys if I walk you through it, rather than having to make you click and drag things if you don't want to, right? Then come Monday, we will go over 311 together, Okay, come Monday, we will go over 311 together, and you will only have to take one of those quizzes, or sorry, one of those tests. All right. I do apologize for